Hi guys, in this video I'm going to show you how to do multiple regression in R, and I'm going to try to be as succinct as possible, leaving out a lot of the theory that we learned in class as well as a lot of the subtle discussions, and try to focus mostly on the code while invariably throwing in some guidance along those lines. Okay, so first let me tell you the data set we're going to be working with. It is already imported, and I've called it FC, and FC is abbreviation for fuel consumption. Basically what this data set is, it's fuel consumption for all 50 states, including I think Puerto Rico, so 51 states, if you will, in the United States. Okay, so if we look at the structure of FC, we see that it's a data frame with 51 examples, and we have 11 features. Okay, so when you look at some of these features, you see they all have to do with fuel consumption. First off, this X is just the name of the state, the abbreviation. Okay, so we're not going to use that for any kind of prediction algorithm. Besides that, you see all the rest of these have to do with fuel consumption. Okay, so you see that it's the population, the miles. Miles stands for miles of highway. Income is the average income in the state. We're going to talk about fuel consumption per person, the number of driver licensed citizens in the state, the gas tax for the state, and the region, whether the state is north or south. Okay, so those are the ones I've circled there or boxed are the ones that I'm going to focus on, and we'll just limit our analysis to those. Okay, so what I want to do here is I want to be able to predict the fuel consumption of a state using some of the other features and characteristics that we have, information we have on that state. So for us, fuel consumption, which by the way is per person, is our target. So here's our target feature. And as you can see, it's a numerical feature. Here's a preview of the first 6 observations for fuel consumption. You see this is a numerical target feature. So you should be immediately considering some kind of regression based technique. And since we have all these other features here, we might consider multiple linear regression or multiple regression as our kind of basis for analysis and prediction. Okay, so fuel would be the dependent variable, our target, and some of the other ones that I boxed earlier, like income and miles, tax, driver's licensed citizens, and region, will serve as our independent features or our predictors. Okay, so basically our job is to come up with a model using multiple linear regression as our framework that will take as inputs some of these features that I discussed, and as an output will predict the fuel consumption. Okay, so that's basically our goal here. All right, now before you would jump in and just apply some of the multiple regression algorithms that R has built into it, you should do some exploratory work. Some exploratory data analysis here might include calculating a correlation matrix using core. Be careful, when you calculate a correlation matrix, you can't include categorical variables like factors and characters. Okay, you'll get an error message if you try to include these. Okay, so you have to subset your features to only those features that are numerical. Another thing you would definitely consider doing here is creating a scatter plot matrix, and that will go a long way to kind of reveal the story between the story of the relationships between these variables. Okay, and it'll give you a visual, okay, to go along with the correlation matrix numbers. All right, but I'm gonna skip that. for purposes of being as brief as I can with this, because we've already done this in a previous module called Exploratory Data Analysis. So go back to those tutorials and see how I was able to create those exploratory tools like the correlation matrix and the scatter plot matrix. Okay, because what I'm going to do now is to just show you how to generate and estimate the regression coefficients for a multiple regression model. Okay, so now that we know we want to predict fuel, and we have decided that the ones I'm underlying here, the features I'm underlying, are the features I want to use to predict fuel, in other words, my independent features, I can define this model using the LM function. First, I will give the independent feature, so that's fuel, tilde, and now I will list out the independent features, the predictors, the explanatory variables, separating them with plus signs. So the order I put these in does not matter. So there's income plus miles plus, by the way, miles is the miles of highway in a state, plus tax. Tax is the gas tax for at the pump. DLIC is the number of drivers, licensed drivers per 1,000 population over 16, something like that. Basically, a higher number for DLIC indicates more capable or more drivers licensed citizens in a state. And region, as you can see, is the only categorical feature we have here. It's been coded as a factor, which is nice. It has two levels. The levels are north and south. So this basically tells you whether a state is in the north or in the south. Okay? And we're going to define our data set. So these features come from the data set FC. Right? Okay? If you hit enter here, you're going to get a bunch of output. I definitely recommend that you assign a name to this model. I call this M1 Model 1. Hit enter. Now we can use the summary function to get a summary of what R was able to do. And we get a bunch of output, and we'll go through this quickly. Here we get a repeat of what we defined, what we called for. Here's our Y, and here are our X's. So here's X1, X2, X3, X4, X5. Okay. Here we get a little snippet of information, summary stats regarding the residuals. Remember, these were the brackets that we drew in class with the little e's, the vertical heights. Remember those? Okay. The kind of crux of all this is the coefficients. The coefficients here, since I have 1, 2, 3, 4, 5 independent features, I should end up with 1, 2, 3, 4, 5 regression coefficients and the intercept. So actually I should end up with 6 estimates for my regression coefficients. Okay, so these are the coefficients, remember? These were the B's that we talked about. These were the partial slopes. Okay? And this one is the intercept. Okay? And this all came together in an equation, and we kind of went like this: y hat equals b1 times x1 plus b2 times x2 plus b3 times x3 plus b4 times x4 plus b5 times x5. And I couldn't squeeze in b0 at the front, but it doesn't matter. I could put it at the end. We're just adding it, so the order I do that doesn't matter. b0, remember, was the intercept, the y-intercept. Okay, so basically now I actually have the numbers for these guys, and those numbers are these guys over here, the estimates, the coefficient estimates. And you can see right next to each number, this one's for the intercept, so this is B0. This one's for income, so for us that's B1. This one's for miles, that's B2, B3, B4, and B5. So we got these guys. So these 6 coefficients actually have values now, and so you can replace them in this equation up here with the actual values, and you could write out this whole equation. Instead of having these b's, you can put these numbers. Okay, and that will be our multiple regression model. Okay, now a word about these coefficients. Okay, you see this e plus 0.02, e minus 0.03, and so on. This is scientific notation. Okay, so I'm going to show you how this works with the first guy. So this is a clean way of writing 3.812 times 10 to the positive 0.02. So positive 2. So what this is saying is multiply 3.812 times 10 to the 2, which is 100. So that amounts to saying move the decimal place 2 to the right. So this equals 381.2. Okay? This is just a way of writing it so that really big numbers and really small numbers can be written here. Okay? Let's just look at the next one. Negative 7.051 times 10 to the negative 3. Negative 3 means go to the left 3. So 1, 2, 3. And place the decimal there. So this equals negative, because it was negative here. That doesn't have to do with this negative sign. Those are two separate things. Negative 0.007051. That's what that number actually is. This one. Okay? And as you see here, times 10 to the 0, that just means just negative 4.115. That's actually what it is. Okay? So just take some care in interpreting these coefficients. They're actually written in scientific notation, so refamiliarize with yourself with this. Okay? Next, we can scroll down and look at some of these model assessments. Okay? So over here we have a section on model assessments, and here you see the stars. These are also a form of assessment. Okay, as you can see, we get codes here for the significance. So 3 stars next to any of the coefficients. So this whole row has to do with income. So 2 stars is saying that this slope is pretty significant. Okay, pretty significantly different than 0. Okay, whereas this slope over here has no stars, so miles of highway in a state seems to not have much of a significant impact on the fuel consumption in a state. So more stars like this one indicate a higher level of significance. And when I say higher level of significance, we're saying that the slope is significantly different than 0. Put in other words, this particular feature has a strong linear relationship with our target, which is fuel. Whereas this particular feature seems to have not a significant linear relationship with our target fuel. Okay, so this gives you some idea of which independent features are contributing something and which are not. Okay. This box down here now, there's a couple things we could talk about. Here's the residual standard error. Okay, that's a measure of the average. It's sort of like an average distance of those e's, those that we talked about in simple linear regression. Okay, and R square here. So here's our multiple R square. This is our coefficient of multiple determination and adjusted coefficient of multiple determination. Notice this guy is slightly higher than this guy. That will always be the case because remember, adjusted R square adjusts R square for the number of independent features that you use. So here, since we had 5 independent features, we had to pay a price for that. Okay, and this one is more useful in scenarios where we want to compare one model to another. Okay, and so there's some other output here that we did not discuss in class. Mostly we're going to be interested in prediction, and in this video particularly I wanted to focus mostly on producing this output and not as much on interpreting it, although we did go through the highlights. Okay, finally, to round this out, I want to use my model that I created, which I assigned the name M1 to make a prediction. Okay, so let me just cheat a little and look at my data one more time. I like to kind of remember what my data was about and how my data was recorded. All right, so let's say there is this there is some kind of political discussion civic discussion on reducing fuel consumption. So since fuel seems to be what we're trying to predict here, for some reason we want to predict what's going to happen to fuel consumption if we tinker with some of these independent features. Namely, what's going to happen if the income goes up, if the tax rate goes down, if you're in a northern state instead of a southern state, and so on. So let's just pick some values for those features. So we use the predict function. We are going to predict using our model that we just created, and we have to feed a data frame of inputs so that it can calculate a prediction. So we use the data frame function, and so here we can just start stating values for our independent features. So our first independent feature, if we scroll up, was income. So we got to define an actual number for each of these 5. Okay, so income. We got to make sure we type it exactly how it's written there. Income equals, let's say, this is, by the way, the average income of a state. So let's say I'm interested to see what happens if my income is 35,000, average income. Miles of highway. So miles. If I only have 50,000 miles of highway, if my what's next? Tax. That's something that policymakers can definitely mess with, the gas tax. If my tax rate is 20%, if my driver's license citizens, there's about 900 driver's license citizens per 1,000 citizens above the age of 16. I'm just making up these numbers. They're reasonable numbers looking at the data. And finally, the region is in the north. Let's say that this, I may have to put north also in quotes. I'm not sure. Let's see if we get an error message. Okay, let's close the parentheses. We've defined values for all 5. Yes, 1, 2, 3, 4, 5. Close the parentheses for the data frame. Close the parentheses for the prediction. Let's scroll back, right? Open, open, close, close. Okay, let's hit enter. Okay, object north not found. Yeah, we got an error for that. So we have to put quotes around this. So hopefully that works. Hit enter. Yeah, that worked. So if a state has an average income of $35,000, 50,000 miles of highway, a tax rate of 20%, and notice I didn't put 0.2 because the data was recorded as if it had percentage signs, so not as decimals. 900 licensed drivers per 1,000 population above 16, and it's a northern state. So those are the kind of characteristics of this particular state. Our algorithm predicts that the fuel consumption per person in that state will be 552 gallons per year. Okay? So that's kind of interesting. So we could do this for any number of inputs. So we can put any values we want here that are kind of within the range of values that we have in our data above, and we will get a legitimate prediction for the fuel consumption per person per year in that state. Okay? We should remember that this is only a prediction and that there is quite a bit of variability in data, and there always will be, especially when you're measuring real world data. Okay? So this was admittedly a very quick overview of multiple regression, and we did it using R, so we didn't want to focus too much on the theory of multiple regression. We covered that in class. I wanted to give you enough functions and functionality so that you can take your data set and apply a multiple linear regression model to it and learn a equation or a multiple linear regression equation and use that in order to make predictions like we did here. Okay, so don't forget that exploratory data analysis is absolutely important here. I mentioned the correlation matrix as one suggestion, the scatter plot matrix as another, probably even more important, and also you can use summary to get summary statistics for the features that you are going to analyze. Okay, and that would come before you jumped in and created M1 and then used prediction to make predictions. Okay? Alright, so I hope this was helpful. Till next time, have a great day.